All right, hello everybody. So today's lesson is 1.6. We're going through writing numbers in scientific notation, changing numbers in scientific notation to decimals, and using scientific notation in problem solving. Okay, so we got a Bellringer, or kind of a warm-up question for the day. So pause the video, work through these questions if you haven't already, and then replay the video or start the video up again when you have them done. All right, so remember, when we are writing repeating decimals as fractions, we have to pay attention to how many repeating places we have. There's 2 repeating places there, so that would be times 10 twice, or 100. So we'd have 100x is equal to 456.56. All right, because we have those repeating decimal places. Remember, to get that 5656, you could just think about this, just rewriting that again, where you move that decimal place over twice. Okay? Then we take our original number, which we call x, and that is 4.56 repeating. Line up those decimal places because now we are going to subtract these 2 things. So we're going to take this away, and that 0.56 will go away. Then we got 99x is equal to 452. All right, because we're subtracting the ones place there. Since that 0.56 goes away, it's like a 6 minus 4, and that's where your 452 goes from, or goes to. Okay? And then we got to divide by 99 to solve the equation. So 99 goes away, and we have x equals 452 over 99. And you can't actually reduce that. Try taking a 3 out, it doesn't work, and it won't reduce. Okay? If you use the fraction to decimal button in your calculator, you'll see that that is our answer. Okay, over here for B, we are using exponents and coefficients here. So multiply the numbers like the 5 and the 3, or 5 and negative 3, excuse me. That gets me a negative 15. And then remember what we're doing with the variables. We have an x and an x squared. We're going to add those exponents because we're just multiplying like terms, okay, or like variables. Okay, that'll get us x to the third. And then we got y to the third and just a y here, so that's y to the fourth. And there we have our answer, okay, simplified expression. Over here for C, we're doing division. So we're going to do it pretty much the same way, okay. We're just going to divide those numbers like normal, so that would get us a 3 over 1. Okay, we might have a fraction in the end, we'll see. And then with the x's, remember, we're moving them to where the larger one is. So this is a negative 3, this is a positive 2, so that negative 3 goes down, and when we move a negative across the fraction line there, it becomes a positive. So now in the bottom, we have x to the 5th. Okay? Same kind of idea with the y's. We got negative y's down here, positive y's up here. We're moving them up. And when we do that, that becomes y squared. Okay? So then we have 7 y's on the top. So y to the 7th. Okay? Right there. If you did subtraction, like our rules explicitly state, okay, we would do x to the negative 3 minus 2, which gets us x to the negative 5th. Okay, and then we know that the negative exponents are going to drop down, and that's where that x to the 5th on the bottom comes from. So you can get the answer the same way, just using our rules, or you can think about moving variables to where the larger one exists. Okay, there wasn't any homework on the previous lesson, so we're just going to jump right into it here. So what is scientific notation and why do we use it? Okay, so scientific notation is written as some number times 10 to some power. Okay, where a, or where the number is between 1 and 10. It cannot be over 10, so it's got to be greater than or equal to 1, okay, right there, and less than 10. All right, so it's just written as something times 10 to the something. All right. Why do we use scientific notation, right? It's a simpler way to write larger numbers. All right, so if you're thinking about some larger numbers you might see in the real world, okay, you might be writing something in the billions as something times 10 to the 9th, okay? If you do anything with astronomy, at any point in your life, okay, you might be looking at the distance from the Earth to the Sun. That's usually in scientific notation if we're looking in meters or something like that. Okay, So anything that's super big, we're going to write it in scientific notation because it's a lot easier to write something like this, like 1 times 10 to the 9th. Or if you're going to write a billion out, then you're like 1, 0, 0, 0. You're going to throw all those zeros on there, okay? It took me a third of the amount of time to do that than it did to do that, okay? So that's the point of scientific notation, writing larger numbers in a simpler way, all right? You probably ran into it in your science classes. If you take a physics class, you'll definitely run into it, okay, because we're working with planetary motion sometimes, and sometimes we're working with things that are itty-bitty like charges on electrons, okay? So either way, really big or really small, okay? So maybe I should write larger or really small, okay? So examples here, here, and here of scientific notation. We're just going to take these and we're going to kind of expand them so we see how it works and see if we can kind of make sense of it on the next slide. So here is our number A. It is less than 10 and it is bigger than 1. Usually that decimal place is going to come right after a number, okay? It's got to be number point something, or it could just be number, okay? So times 10 to the 6. 10 to the 6 is really a million. So we're taking 3.2 times a million, all right? Because if you think about this at its basic level, you're writing out 10 6 times, so that would give you 6 zeros, okay? The easy thing with scientific notation is if we know that that number is getting bigger, we're going to take that decimal place and we're going to move it to the right, all right? So you would move that decimal place to the right 6 times. So 1, 2, 3, 4, 5, 6. That's where that decimal place is going to land, and all these open spaces are going to be where zeros go. So this number is actually 3200000. So 3,200,000, okay? Because we're moving that decimal place to the right 6 times. So if you want to just kind of associate things with directions, positive exponents, move the decimal to the right. Okay? So positive exponents are going to move things to the right. So this one right here, think about it. How many times are we moving that decimal place? Well, it's the third power for 10, so we're moving that decimal place 3 times. So 4, 1, 7, 6. And if you wanted a decimal there, you can. But when we have whole numbers like this, we don't really need a decimal. Okay? So it's 4,176 if we expand that out. Okay? So here's the other one. We have a negative exponent. If positive exponents move it to the right, negative exponents must move it to the left, right? So on a number line, think about negative numbers. Negative numbers go to the left. Negative exponents are going to move the decimal to the left, okay? So if you need to write yourself some notes, go ahead and do that. And we'll look at this one, okay? So this tells me to move that decimal place to the left 2 places because it's a -2. Or I'm really dividing by 10 twice. So 1, 2. Right there's my decimal, okay? Remember on the open spaces, you're going to put a 0. And here, you got to have that decimal because we have a smaller decimal when we're doing this, all right? So this number expands out to that, so 0.0264 or 264 10,000ths, okay? So that's pretty much the basics with scientific notation. So we can expand them. Now let's look and see how we write them back in scientific notation. So these 3 questions are all expanded already, and we want to condense them, or we want to write them in a simpler version of scientific notation. All right? So remember, when we write scientific notation, that number, so number times 10 to the something, this number, A, needs to be greater than or equal to 1 and less than 10. All right? So when in doubt, on these basic ones, go to where it's just a plain number less than 10. So this one is going to be 4.56, but then we got to look and figure out how many times we move that decimal place. So the decimal place is always at the back of the number when we're working with whole numbers, and we're moving it 1, 2, 3, 4 places. So that would be times 10 to the 4th. Okay? Now, you might be thinking from the last slide, well, Henricks, you said if the decimal place is moving to the left, that's negative. That's only when you're expanding them back out, okay? When you look at your answer, it needs to be able to go back to that. So if I expanded this back out, positive exponent means it moves to the right 4 places. It's a larger number, okay? So if I am making a bigger number smaller, that should be positive. If I'm starting with a bigger number, that should generally be positive. If I'm starting with a smaller number, then our scientific notation, our power of 10, will generally be negative, okay? So again, smaller, 10 to the negative something, okay? This one, larger, 10 to the positive something, okay? So how are we going to get this answer here? So we're looking for that to be like a 3 point something, okay? Because we're going to have it less than 10. We can just think about getting a number less than 10. So right there is where our decimal's got to be. So in order to get it there, we have to move it 1, 2, 3 places. So it'll be 3.026 times 10 to the negative third, because we moved it 3 places, all right? And now again, if I think about expanding this back out, if I have a negative exponent of the 10, it tells me to move the decimal place left, and I would get back to where I started right there. Okay? So go ahead and give the last one here a shot. Pause the video for a couple seconds if you need to, and then check your answer. So looking at this, the first number that I see, if I'm moving my decimal place, is the 4. So I want this to be a 4.8, okay, and times 10 to the something. So this is a decimal. It's a smaller number. So we're moving that decimal place here to be a 4.8. So that's 1 place. Moving it, that should be a negative 1, okay? Starting with a smaller number, the exponent is more than likely going to be negative, okay? So that's how we write a regular number or a decimal or a rational number into scientific notation, all right? Okay, so we've already talked about how to do this, but I'm going to introduce one more thing here with these before I have you expand them out, okay? And that thing would be significant digits, okay? So when you're in any science class or when you're working with scientific notation, you want to maintain the same amount of digits that you started with in your scientific notation, okay? But you have to know if they're significant or not. So rules to significant digits, the first one would be any non-zero number is significant, okay? So in this one, the first one, number 4, 2, 8, and 3 are all significant. So I would count that as 3 significant digits, or you might hear them called sig figs. So when I write this out, I should have 3 significant figures in the end, all right? For number 5, I have 2 significant figures because they're both non-zero. Okay, so when I write out my expanded form or my scientific notation, I should have 2 significant figures. And then 6 brings in a different rule, so we'll get to that in a minute. But number 2, any 0 in between 2 non-zero digits. So like if I gave you 3,023, that 0 is between 2 non-zero digits, so I would have to count that 0 as significant. So this one would have 4 significant figures, all right? So if I wrote this out in scientific notation, it'll be 3.023 times 10 to the something, okay? It'd be times 10 to the third in this case. So a lot of the times when you're working with scientific notation, just straight up mathematics with scientific notation, it will end up it'll end up using significant digits, and you won't have to worry about it. But if you have something like number 6, then you kind of have to worry about it a little bit, okay? So that brings into rule number 3. Any 0 to the right of a non-zero digit of a decimal, all right? So I call these things trailing zeros. And the trailing zeros are always right of a decimal, okay? So with number 6, if I'm looking at rule number 1, that 0 would not count because that's not a non-zero digit. Also, rule number 2 would not count because that's not between 2 non-zero digits, okay? That is all the way to the right of the decimal, so that brings in rule number 3. So this would have 3 significant figures, all right? Let me show you something that you might confuse with rule number 3. So if I had 3,800, okay, you might be like, well, Henrik, you said something to the right, like zeros all the way to the right count, right? Well, these are zeros all the way to the right, but they are not all the way to the right of a decimal. So those do not count, and this will only have 2 significant figures, or 2 significant digits. So when you write it out in scientific notation, you should only have 2 significant figures, okay? So most of the time for this class, it'll end up working itself out, all right? But these are rules just so you kind of see them once, kind of an FYI. Maybe you heard about them in physical science. If you plan on taking any chemistry or physics, you'll see them again, all right? So go ahead and pause the video, and I want you to expand these 3 questions out and make sure you have the correct amount of significant figures when you expand them out, and then go ahead and play the video again and watch for the solutions. All right, so the first one, 2.83 times 10 to the 4th. 4 is a positive. That means this number should get bigger, okay? We're moving that decimal place 4 spaces to the right. Positive exponent of 10 means 4, or means to the right. So it'd be 2,830, okay? 28,300. That would be the expanded version of it. Do we have correct significant digits? I have 3 here. I have 3 here. And again, remember, those don't count because they're not trailing behind a decimal. All right, number 5, negative exponent. Negative exponent means this is getting smaller because it's going to be moving the decimal place to the left. So we go 1, 2, 3. Put that decimal down. We got 2 spaces here. Okay, those are where zeros should go. So 0, 0, 3, 8. Do we have correct significant figures compared to how we started? We have 1, 2 there. We have 1, 2 there. Okay? Now you might be thinking again, well, there's a trailing 0 there. It's a 0 to the right of the decimal. Okay? Trailing zeros are zeros all the way to the right of the decimal after a non-zero digit. So if we had zeros back here, those would be trailing zeros and those would count. Okay? So this is our answer here. And then last one here. So how many sig figs do we have to start? We have 1, 2, 3. That one counts. That's a trailing 0. So we need to have 3 when we're done. Okay? Negative exponent means move this to the left. 1, 2, 3. Put those zeros in that decimal there. So 0.00380. I have to have that 0 there because I have to have 3 significant digits when I'm done because I had 3 of them to start. Okay? So this is where this kind of thing looks a little goofy because the 0 doesn't really mean anything, but it does mean something when we're looking at significant figures. So this would be what we would have to have as the answer. Okay? If you're kind of confused on this, you might want to look up another thing on significant digits. There's videos that are specifically about significant figures. But like I said, most of the time, if you just take whatever number you have written there for your scientific notation and follow the rules that we have for scientific notation, move to the left or move to the right, you will end up getting the correct answer in expanded form. All right? So last thing we're looking at is doing operations with scientific notation. So operations with scientific notation follow the same rules as our exponent properties. Just multiplying things with variables and exponents, it's the same kind of deal. If you wrote number 7 kind of like this, and this, okay, we can multiply the 10s together and add the exponents. You can multiply the 8 and the 6, and then you would have a number times 10 to the something, okay? In this case, it would be 48. So maybe you don't like writing it that way. If you don't, then multiply those front numbers. Okay, our number A would be 48. And then we multiply the 10s using our exponent property. So 10 to the 4th times 10 to the 3rd. Okay, that'd give us 10 to the 7th. All right, you might feel like you're done here because you're like, I multiplied and I got my 48 and I got my 10 to some power. However, we have to make sure that we look at this front number and ask ourselves, does it follow the rules that we were using with scientific notation? Is that a number that is less than 10? No. So that's where this gets a little bit tricky, okay? So I have 48 and the decimal is back here. So I need to make this 4.8, okay? So think about it the same way as what you did before. I got a bigger number, and I'm making it smaller, so that means bigger number, this should be positive, okay? Since that should be positive and I'm moving that decimal place, I'm going to add to that exponent when I move that decimal place, right? Because if I move that decimal, that should be positive. We write how many times we moved it, okay? So in this case, we moved it one place, so we should add those together, and we get 4.8 times 10 to the 8th, okay? So let me kind of give you another example here to kind of make sense of that one. Okay, so let's say we just had that. That would be 4.863 times 10 to the third, right? Because it's a bigger number that we're making smaller, so the exponent should be positive. Now, if we have that number there with a scientific notation already, again, bigger number, exponent should be positive. Put the plus because you know it's going to be positive when you move things around. So we'd have to move that decimal place 3 to get that in scientific notation. So positive 3 when you do that. 4.863 times 10 to the 7th. Okay? That example wasn't on your notes, but it's just kind of something to relate it to this. That way you can kind of see how to do it with another example. So use the same rules. If you have a bigger number, those exponents should be positive. Oops, I got rid of my answer. So positive means add. Okay? Looking at number 8. What are the rules that we use for exponents when we are subtracting? So I'm talking about these right here. So 10 to the 13th over 10 to the 8th. What are you going to do with those exponents? Well, we're dividing, so we subtract the exponents from the larger one. So it's going to be 13 minus 8. So we'll have 10 to the 5th. Okay? Then we got to worry about these. So we do this the same as number 7. 7, we multiplied the 8 and the 6. So number 8 here, we're going to divide the 3.154 and the 1.577. And that's actually a nice number. That's just actually 2 if you put that in your calculator. So it'd be 2 times 10 to the 5th. And then again, ask yourself, after you do these operations, do I have to worry about rewriting it in scientific notation or changing it to like true scientific notation like we did in that one? Well, 2 is less than 10. It's greater than or equal to 1. So that is done. Okay? So number 9. Looking at number 9 and 10. Go ahead and try those on your own. Pause the video and then come back in a minute or so and see if you got the right answer. Okay, so number 9, we're going to do that just like number 7. We're going to multiply the front numbers. Okay, so if we do that, you might need a calculator. We get 25.07 when we multiply those out. And then we multiply our tens. Okay, this one's got a negative exponent. This one's got a positive exponent. We add those because we're multiplying. So this should be times 10 to the 20th. All right? And now, right there, 25.07. Is that number less than 10? No. So we got to make it less than 10. When we make it less than 10, again, ask yourself, is this a bigger number or smaller number that I'm changing? Okay, bigger number means positive when I change it. So I'm moving that decimal place 1 time. So that means you're adding 1. So it's 2.507 times 10 to the 21st power. Okay? So really kind of go back to your base rules for scientific notation. Is the number bigger that I'm turning into a smaller one, or is the number smaller that I'm turning into a bigger one? And use the rules associated with that. Okay? Number 10, you've got a couple ways to do it. You could throw 500 times 3,500 in the calculator and then change that into scientific notation. Or you could change them into scientific notation right away and worry about it after that, which that's the way we're going to go about it. Okay? So how are we going to write this in scientific notation? How are we going to write this in scientific notation? So that right here, the 500, should be 5 times 10 to the second. We move that decimal place twice to get it less than 10. All right, the 3,500 should be 3.5 times 10 to the, how many times did we move that decimal place? 3 places. All right, And now we can use the calculator a little bit. This might be, if you did it the other way, you multiplied the 500 and 3,500 and then went about scientific notation, that's fine. Okay? You can use a calculator. It's going to help you out on this stuff if you don't remember the rules completely. But we're just practicing scientific notation stuff here again. So 5 times 3.5, that's going to be 17.5. And then exponents of 10, we're going to add those together, times 10 to the 5th. And then ask yourself again, is that number less than 10? Doesn't look like it. 17 is bigger than 10. So bigger number, add to that exponent. We're moving it one place. So 1.75 times 10 to the 6th. And there you have it. Okay? So we've covered basic scientific notation, changing a number into scientific notation, and going the other direction, changing a scientific notation number to expanding. And then we covered significant figures, and we covered operations with scientific notation. All right? So hopefully that lesson works well, and there is your assignment, and you'll be getting a worksheet for this assignment. So thank you for watching. Good luck on the homework, and let me know if you have questions.